Hello to all dear students. In this video, we will be discussing about correlation. The word correlation is used in everyday life to denote some forms of association. We might say that we have noticed a correlation between foggy days and attack of dizziness. Okay, so whenever there is a cold climate, we'll feel a bit, we'll be suffering from cold, isn't it? So that is a kind of correlation. However, in statistical terms, we use correlation to denote association between two quantitative variables. Like, for example, as you can see on the screen, temperature versus ice cream sales. Okay, so as the temperature increases, the ice cream sales also increases, isn't it? So, this is a kind of correlation. In cold climate, we'll not have ice creams, will not consume ice cream in cold weather, but in hot weather we do consume ice cream, isn't it? So we can easily see that warmer weather and higher sales go together, and this is a kind of good relationship. But suppose there has been a heat wave and it is so much hot that people are not going outside in the shop for purchasing ice creams. So as the temperature is too much high, so the ice cream sale also reduces, as you can see in the graph. The correlation value is now 0, no correlation. But we can see the data follows a nice curve that reaches peak around 40 degrees. But the correlation calculation is not smart enough to see this. Okay. We'll have one more example like sweet consumption and weight gain. So this thing to you people know aram se. Whenever you are consuming more sweet, the weight gain also increases, isn't it? Simultaneously, whenever you are consuming more amount of salad, healthy food, so weight gain will be in the negative way, because as more you are consuming salad, the weight gain will be reduced. As you can see in this second table, when you are consuming 5 kg of salad, the weight gain is 3 kg, but when you are consuming 25 kg of salad, weight gain is -1, means there is a weight loss. Okay, and for your information, this chart just I made. Okay, do not consume 25 kg of salad and you are expecting -1. Okay, just for an example I'm writing this. Okay, so sweet consumption more, weight gain is more. Salad consumption is more, weight gain is less. Okay, so this sweet consumption and weight gain, this is a kind of positive correlation. Okay, positive correlation means when one variable is increasing, then the second variable is also increasing. Okay, as your sweet consumption is increasing, weight gain is also increasing. Whereas the second example, it is a kind of negative correlation, means if one variable is increasing and the second variable is decreasing. Okay, your salad consumption is more, your weight gain is less. Okay, so we have got a positive and a negative correlation. So correlation can be positive correlation or a negative correlation. Next, one more thing. So we saw this salad consumption and weight gain. Okay, so weight gain not only depends upon salad consumption. Okay, so this thing was a simple correlation, but weight gain totally does not depend upon salad consumption. It also depends upon hours of exercise you are doing. Okay, so now as you can see, weight gain now it depends upon two variables. Okay, now it is depending upon two variables, so this is known as partial correlation. Okay, so previous thing what we saw was simple correlation. Simple correlation means study of two variables. Okay, like weight gain and salad consumption, that was the two variable, so that was simple correlation. Now in this case, partial correlation means study of usually three variables. So what all are three variables? Salad consumption is the first variable, weight gain is second variable, and hours of exercise is the third variable. So whenever we are studying three variables, it is said to be partial correlation. Now, weight gain not only depends upon salad consumption, hours of exercise, it also depends upon mental stress, it also depends upon workload. Okay, now as you can see, the number of variables have been increased more than 3. So now in this case, we call it as multiple correlation. Okay, multiple correlation means study of more than 3 variables simultaneously is known as multiple correlation. Fine. So a correlation, it can be positive or negative, plus it can be a simple or partial or multiple correlation. Next, one more thing, we are checking out the relationship between income and expense. As you can see, whenever the income is 20,000, the expense is 10,000. Income is 40,000, expense is 20,000. Income is 60,000, expense is 30,000. Income is 80,000, expense is 40,000, and so on and so forth. Okay, so as you can see, whenever the income is increasing, the expense is also increasing, your lifestyle is also increasing. Okay, so as you can see, it is a kind of no linear relationship. If changes in one variable tends to be constant ratio of the second variable, it is said to be a linear relationship. Okay, constantly it is increasing. If income is 20, expense is 10. If income is 100, expense is 50. Okay, so there is a constant ratio in the increase of the variable, so that is known as linear relationship. But there are few people, like as you can see in the second example, income is 20,000, expense is 10,000. Okay, income is 40,000, expense 20,000, that is also okay. Income 60,000, expense 30,000, this is also okay. Income 80,000, but expense over here is 20,000. Okay, it is 20,000. Income is 100,000, expense is just 15,000. Income 150,000, expenses 40,000. So do you see any kind of constant ratio changes? No, isn't it? There are few people whose income is less, they are expending more. There are few people whose income is more, but they are expending less, isn't it? So this is known as non-linear relationship. Okay, this example is for linear relationship, and the second example is for non-linear relationship. Non-linear relationship, also known as curvilinear relationship, means if change in one variable does not tends to bear constant ratio changes in the second variable, that is known as non-linear relationship. Okay, so correlation are of three types. It can be positive or negative, it can be simple or partial or multiple, or it can be linear or non-linear. Next, correlation coefficient. Instead of drawing a scatter plot, a correlation can be expressed numerically as a coefficient ranging from -1 to +1. When working with continuous variables, the correlation coefficient to use in Pearson's, that is designated as small r. Okay, so as such, we have seen that to determine the relationship, we are drawing a scatter diagram. Like initially I have shown the diagram for temperature versus sales in ice cream. So instead of drawing scatter diagram, we can express it numerically in between -1 and +1. Okay, so this is a scatter diagram, but we can express it in numerical way. Like the correlation coefficient small r indicates the extent to which the pairs of the numbers for these two variables lie in a straight line. Like a correlation of -1, it indicates a perfect negative correlation, meaning that as one variable goes up, the other variable goes down. Similarly, a correlation of +1 indicates a perfect positive correlation, meaning that as one variable goes up, the other also goes up. Fine. Last thing is correlation versus causation. A correlation between variables, however, does not automatically mean that the change in one variable is the cause of the change in the values of the other variable. A correlation only shows if there is a relationship between the variables. Like as you can see in the image, here it is showing a hot weather. Because of hot weather, you are consuming more amount of ice cream. Because of hot weather, there is large amount of sunburn, so you are using some kind of lotion. But there is no correlation between sunburn and ice cream. Because of sunburn you are consuming ice cream, or because of ice cream there is a cause of sunburn? No, isn't it? There is no correlation between sunburn and ice cream. Okay, because of hot weather there is sunburn. Because of hot weather you are consuming more ice cream, but no correlation between sunburn and ice cream. Okay, so there is correlation, but there is no causation. Okay, so and this was all about my video regarding correlation. In the next video we'll be discussing about Carl Pearson's correlation. I hope you people found this video helpful. Thank you for watching.